Okay, for the last portion of the notes, we're going to be dealing with density. And these are fairly simple and self-explanatory. You've probably done this in other science classes, but density is the amount of matter present in a given volume of a substance. The units are either grams per milliliter or grams per centimeter cubed. And so 1 milliliter is equal to 1 centimeter cubed. And that's why they are used interchangeably. And I think I stated this earlier in the notes. Density is equal to mass over volume. So that is the equation. D equals M over V. The density of a liquid can be determined easily by weighing a known volume of the substance. And so here, suppose a student finds that 23.50 milliliters of a certain substance weighs 35.062 grams. So here is our milliliters, which is our volume. And here is our mass in grams, and we want to know the density. So all we're going to do, plug in mass over volume. We have 35.062 grams over 23.50 milliliters. We get 1.492. That ends up being the correct number of significant figures. 4 significant figures is what we're limited to. Our units here are grams over milliliters. Right there. The volume of a solid object can be determined indirectly by submerging it in water and measuring the volume of water displaced. So think of when you get into a pool or a bathtub, the water rises. That's equal to your volume. And so if someone is fully submerged in a pool, then the amount it rises is going to be the volume of that person. So here, this problem says a student weighs a metal object and finds the mass of the metal object to be 55.64 grams. That here is going to be our mass. She then places the water in a graduated cylinder and measures the volume of the water to be 75.2 milliliters. When the metal object is placed in the water, the new volume is 77.8 milliliters. What is the density of the object? So we have the mass right here. What we need is the volume. The volume is just going to be the difference in these two. So we're going to take 77.8, 75.2, 6, 2, that's just 1 decimal place. So 2.6 milliliters is our volume. So density equals mass over volume, and so it's 55.64 grams over 2.6 milliliters. That equals 21.4 grams over milliliters. Because we're limited by 2 significant figures here, I'm going to cut it off right there. 2 significant figures, and so we get 21 grams per milliliter. And that is our answer, 21 grams per milliliter. For the next problem, it says a diamond has a density of 3.26 grams per centimeters cubed. What is the mass of a diamond in grams that has a volume of 0.350 centimeters cubed? So what we're looking for here is the mass. We've got D equals M over V, and here M is going to be our X. And so we need to solve for that. And so we need to figure out an equation where M equals these two. And so what we're going to do is multiply both sides by volume. We're going to do some algebra here. Cross that out, and we get that M equals dV. So if M equals dV, M equals 3.26 grams over centimeters cubed times 0.350 centimeters cubed. We're going to multiply that. 1.141 is what you should get in your calculator. Here we're limited by 3 significant figures. Each one has that. So we're going to cut that off to 3 significant figures. End up with 1.14. And then the units, the centimeter cubed, cancels here, leaving us with grams. And our answer is 1.14 grams. The last problem says, what is the volume? So now we're looking for volume of a sample of liquid mercury in milliliters that has a mass of 76.2 grams, given that the density of mercury is 13.6 grams per milliliter. So here we've got D equals M over V, and what we're looking for is the volume. And so here we have to rearrange it so that volume is by itself but also on the top. And so first I'm going to do what I did before, multiply each side by volume. That just gets it so that it's not on the bottom of a fraction. Then I get M equals dV, and now I can divide both sides by the density, and I get that volume equals M over D. Here I'm going to plug in my numbers. The mass is 76.2 grams. The density is 13.6 grams over milliliters. If you look at how the units cancel, you've got grams on both sides. This is in the denominator of the denominator, which is going to end up moving it to the numerator. And so we end up with 5.60294. And so we need to cut this off to 3 significant figures. And so here would be, right after the 0 would be 3 significant figures. And so we get 5.60 milliliters for our answer. So this concludes the density portion of the notes. This concludes chapter 2. We have significant figures, we have conversion factors, and this is density. And so you need to go over these, make sure you understand these concepts. There will be practice worksheets to practice this. And then also make sure you watch the videos and read the chapters.